It's your friendly neighborhood Spider-Man here. Dean had emergency, so he called me, because I'm his #1 fan. I wasn't able to fix it with my web shooters, but he managed to fix it with his printer. If you want to find out how it turned out, jump on my back and let's web sling out of here. Hey everyone, welcome back to all new episode of Makerspace. Unfortunately, Spider-Man had to step out for a bit. He said he had to tend to emergency, but he'll be coming back real soon, so you guys are going to have to keep your eye out for him. On today's episode, we had an emergency, and that's why I called Spider-Man. But unfortunately, Spider-Man couldn't help us, so we ended up turning to our trusty 3D printer. You might be asking, what else can you do with a 3D printer? Well, today I'm going to show you exactly what we can do with a 3D printer. So you might be asking what the problem was. Well, a family friend of ours called Barry, hey Barry, to tell me that his ice machine had stopped working. Now in Africa, you might know it's quite hot, so we definitely need our ice. What happened was the ice machine's feeding mechanism that lifts the ice from the prepared area into the ice bucket had snapped off. So there was no way of the machine working, and basically the machine would have to be thrown away. So I said to him, not a problem, Barry, bring me the ice machine and bring me the broken part, and what I'll do is I'll make you one from scratch. And that's what I did. All right, so this is what the item looked like when I got it from Barry, right over here. Now the next step, what you would need to do is you would need to try and get the measurements of that item, write them down, and that's what I did. I got a digital caliper and I was able to measure all the corners, the length, the width, the height, the thickness, write all that information down, and the next step I would do is take all that information out and move it over to a 3D modeling program to model. It's not that difficult. I know it sounds a little bit overwhelming, but it really isn't. So that's what I'm going to show you next. All right. So I am using this program. It's called Autodesk 123 Design. It's a very basic program, and what this program allows you to do is take any measurements that you have in the physical, and you are able to enter them into this program by a couple of very basic things. Now, what they are would be very primitive box, sphere, cylinder, and cone. There are a little bit more, but I'm not going to go through into it too much. But what I will do is I will leave a link in the description below that you guys can find a tutorial that I did to learn a little bit more about this program. It's not very difficult. It just takes a bit of time to get used to, and the idea of working in the three-dimensional space with numbers and with measurements and so forth. But I will show you exactly underneath my projects. I'm going to go and open my projects. You'll see there's a couple of projects that I've been busy with, but in this instance, I'm going to open the first item that I had worked with. This is a very, very crude, basic outline of what the ice tray looks like. I've taken a couple of measurements from the width and the thickness of the item, and all it is a very primitive box that I've taken and I have changed the measurements of. So you'll see that there's a measurement of 20, and this you can change like that to certain lengths, and you're able to get a square in that particular order. And then you are able to mimic the size and the thickness, which I've done. So all I've literally done is I've created the same thing. These would be cut out items because there's a gap on either side with the hinges, and there is a bit of a 45-degree angle which I've just angled the items through. So this is a very basic, crude design that I started off with just to get the measurements right. From there, the next design, I saved it just to get an idea of the measurements and the sizing. The next thing I did was I opened up the next section, which is this one that you'll see here. All right, so you can see it's a little bit more sort of, it looks a little bit more like the ice machine. I had managed to cut the items, the blocks out on either side of the ice tray or the ice scooper, and I just merged all the blocks together. And all I did was I imported a couple of spheres, I measured them, and I turned them to an angle, and I basically attached them like that over there. All right, so the next step we need to do is export this model that I've just created, the first prototype, to print it out to see the size, any shrinkage, the hinges itself on either corner, if the hinges are correct, because these hinges, as I said, were measured off exactly what the 3D tray gave me off of my digital caliper. So what we would need to do is let me delete the cylinder. We'll come up to the top of the program, the file, and we're going to be exporting it as a 3D STL file. That is the file that my slicing program uses. I'm going to select STL. I'm going to be using a fine mesh. I'm going to press OK. I'm going to give it a name, which we can do now. Once that's done, we're going to open up the STL file, which where we saved it to. I've already done that just to speed it up a little bit. So this is what it looks like in the slicing program I use, Cura. And as you can see, it's going to take around about 9 hours. All I'm basically doing is printing this item as quick as possible, because all I'm after is the sizing and the dimensions of the actual print. I don't care about quality or the infill or anything. So I'm using a very basic infill. And I'm using support structures for the side of the 3D overhangs off the back, the 45-degree section at the top where the ice actually slides on. So what I'm going to be doing now is I'm going to be exporting it to an SD card, and I'm going to be taking that SD card directly to the Ultimaker 2. So what we'll do next is we're going to be running the high-speed footage of the prototype print 1. So if you guys are ready, let's roll that footage now. All right, so the prototype came out perfectly. The measurements were 100%. The only thing I wasn't happy about was the hinges. The hinges came out too thick and they weren't able to fit into the ice machine. So what I ended up doing is I went back into Autodesk and I shrunk down the hinges, and what I ended up doing was printing another one just to see if those hinges would work properly. But what I found halfway through the print, the hinges were way too small and they would break off quite easily. So what I ended up doing then is I went back into Autodesk and I lined up four or five cylinders at different diameters to print out on the 3D print. And once it was done, then I could see the shrinkage of the cylinders that would work perfectly on the item. So the final print, I would just measure those cylinders on either side and they would be the correct size that they would fit into the ice machine. So that's what you guys are going to see next. All right, so now that we've seen those prints and you understand what I've done, I've taken those measurements from those prints, learned from them, and I've taken all that information and I've come back into Autodesk, and this is what the final 3D model looks like. I think it looks very similar to the actual ice tray itself. I've made a couple of changes. I've put the small little blue parts. These are just cylinders that I've laid on the middle of the item and at the top of the model, just to allow the ice to slide down nicely when it picks the ice up. The next step would be to export this to a STL file, which I've done, and to open it in Cura, which I have done. So this is what the ice tray looks like. I think it came out pretty great. I've changed a couple of settings. I've made sure that to print with the support structure due to the overhang at the back. and I'm not going to be printing with a brim or anything. I'm going to be printing directly onto the printer bed, and I'm using a 35% infill, and the quality of the print is the highest quality print that the Ultimaker can put out. And you guys will see now it's going to take about 14 and a half hours to 15 hours. It's going to consume about 5 meters of PLA filament, 39 grams of filament, and the cost would be in around about 20 Rand South Africa, and I will put in the exchange rate that you guys actually see what this cost in your own currency. All right, so the next thing we need to do is to export this file over onto an SD card, move it to the Ultimaker, and then you know what's next. It's the time lapse. So let's get ready to run that now. Hey everyone, thanks so much for watching this week's video. I hope you really enjoyed it. If you liked the video, please be sure to give me a thumbs up down below. And remember to share it with all your friends and family. Click on the subscribe button to stay up to date with all our new videos as they get released. If you have something you want me to print, leave it down in the comment section below and I'll be sure to add it to my print list. If you haven't seen our previous videos, you can click on them now, or you can find a link in the description below. Until next time, I'll see you in the next Makerspace.
Hey everyone, it's your friendly neighborhood Spider-Man here. This week we had emergency, so Dean called me, his #1 fan. I wasn't able to fix it with my web shooters, so we had to turn to his 3D printers. If you want to find out what happened, jump on my back and let's web sling out of here!